Hello, I would like to show you my small project, the MCU pin setup, which is hosted on hackaday.io, and as you can see there are some fancy images about this project here, and I've made a very detailed description, and I have some more stuff to read here, and I won't read it aloud because of course you can come to this page and read it yourself. I just want to show the tool itself. So this MCU pin setup tool is an online pin layout setup tool, which is located here. I click on this, and it is JavaScript based, so it needs a bit of time to load. So now we can see one module, an Arduino Pro Mini, and on the left side we can see some peripherals. Some of them are on, some of them are off, and as we can see, this is a drop down with serial selected. I will talk about this later on. We can hide and show the GPIO pins, so we can locate all of them, or if we don't need to see everything, then we can hide all of these. Also, for every peripheral we can just expand them and see the pin and where is it attached to. And of course, if I open one that is off, it won't show anything to me. So if I turn this on, it will show every ADC channel or pin, and as you can see, the last two are only ADC, so I cannot turn them off or on, but the others can be just toggled to see which pin are they on, and if I would like to use that or some other one. And I can see some description here. I took this from documentation. It may not be the best, and I am constantly trying to do everything to make this better and better. So about this serial, if I look at the description, it says that this can also be used in master SPI mode. So not many of you may know about that, but you can use this also for SPI. There is no slave select pin for this, but it can be used as an SPI. And also we have another SPI, the standard one. I will turn off the ADCs so we can see them both. So if you, for some unknown reason, would like to use this with both of the SPIs, then you're free to go. But if you don't know how to do that, then this tool will help you with that. I will come to that later on. For now, let's just check this drop down menu, and here there are other modules. For example, the ESP main module, and for this we have a bit more peripherals. They are off, mostly well, the things which are on are the default ones. For example, the serial, the first serial, but I can also use the other serials as well. And you may have noticed that I can use them with the CTS RTS mode, or with the first it even has the DSR DTR mode, and if I just click this, then it will show us where exactly are those pins. And if I open this, it will show me when they are, and I even can tell it to just put it somewhere else if I would like to have it on another pin. I mainly did this tool for the ESP32 because nearly for everything you can put all these on different pins. There are exceptions, for example the ADC here is just on and off. Of course the I don't know how to pronounce it, HALL sensor can be turned on and off, but this doesn't have no effect for now. But I would like to do this, that if I turn this on, then it will show a big red exclamation mark here, because this sensor uses channel 0 and 3 if I remember correctly. I will need to look that up and put it into the tool. So you cannot just use the ADC channel when the sensor is on. It will allow that, but you will have the big error message that you are an idiot trying to do something which you should not. And if we go to the other ESP module, we can see that there are more things which are just there. I cannot change the SPI because this is not rooted out. For example, I cannot change this one either, this HS1, which is the SDIO host interface, because yes, it is not rooted out. It is used for the onboard QSPI flash chip, which is there on the SparkFun thing, and it's the SPI which is used for that one. If we go back, then we can see that it can be used, it can be turned on to different modes, and there you go, it's down there and can be changed even to 8-bit mode. I'm really looking forward to this one. What will this do? Because you know, if you use this, then you don't have the SDIO one or even the flash. Okay, let's get back to the showing off part. So this tells that the SPI is on board, and I can set the CS1 and CS2 here, so other flash chips can be used, but the main is not rooted out. Also, if I go here and check the pins themselves, I can see that this is connected to the crystal, which is right beside it here. And if I check this pin, it shows that it is connected to the LED next to the pin. And if I look at the reset, it will note here a very long text, which tells us that this is actually the chip power for the MCU, because the ESP32 doesn't exactly have a reset pin. It's just connected to that. And okay, if I go to the Maple Mini, for example, then we have other peripherals available. No description here yet because I didn't have time for this one. I'm now concentrating here on the Arduino Pro Mini, and I will show you why. We have here a code flavor drop down menu, and I, for example, select the Arduino flavor, and it will generate for me two files. One main file, which includes the other one. This calls the initialize in the setup, and it has an empty loop. And here we can see that in initialize the serial.begin is called. Here you can set the baud rate. Well, of course I can't set it yet because I didn't implement this. It just copies the number, and the number is just there, but it will be a drop down box, and whatever you select here will be there. If I turn it off, and then it disappears and you can't use the serial. Also, if we will use the serial, we can have some other things to set. And if we set the SPI, then it disappears, and this is the part which is not written yet. Many parts are not written yet, but in this case there should be some code here which initializes this SPI, and you could use it in your project. So just by clicking here could provide you the interface, and you just don't need to write a single line of code, just use it like the serial. And if I go on and, for example, turn on the SPI, it includes the header for that one, and it begins that. I can even go on with the I2C, and that's what I did, so nothing else is making here a difference. But I will show you that also we can have these options here where I, for example, turn it to slave mode, master off, and it will add this slave address here, which is also not selectable, but it will be for example an integer with a minimum and maximum range, and this will be copied here. This is exactly copied here now, just I cannot change it here, and it will add the request and receive callbacks. And if I go into the main file, I can see that it added here the automatically generated uh, callbacks, so you just need to put your code here. I've done this also here with the master SPI and slave SPI. So if I turn the SPI into slave mode, then we have here the interrupt routine, which is called when something comes in. And if we go here, I've copied this code from somewhere. I don't know if it is working or not. I will work on this more, but you get the general idea, I think. And the code flavor here is for those who may want to use just simply C or Arduino FreeRTOS, or just simply FreeRTOS, or anything you may like. I have this for now, and it is a bit more complicated here with some hash defines. I know it does not look very good, but I made it just to test it if it works also with the ESP32 board, because I have one, and here also can be used with the Arduino FreeRTOS, and it calls the serial.begin, which is my serial.begin, and I have one print for myself. I just put here a print and nothing there in the begin. It was just to test if it would go the same with this and the Arduino. I mean, it's insane, but I just wanted to try it out. Going back to the page at Hackaday, I've put here the code that actually worked on both Arduino and ESP32, which is just a simple blink and serial printing inside a FreeRTOS task, which is going on an infinite loop, and this loop here is just an idle task which does nothing at all. So basically this is what I aim for. I want to put many available boards here. I would like to have sanity checks, so it would show exclamation marks and warnings and everything if I turn on and off things. And if I generate code from this, then it should be done for every possible peripheral, even the GPIO. For example, I could set everything to output or input pull-up or anything I wanted, and in the initialize MPS it would set the pins to the thing I made in the initial setup. So in my main code I would call initialize MPS, and it would do everything to set things for me. No need to do some very serious initializing stuff, just use the code. And with this it could be made into a board, how to say it, mm, cross-board application, so you wouldn't need to touch the application code, just use another generated layer for the other board. For example, here you do something for the Maple Mini and do it somehow else on the Blue Pill or something else. It's really very small comparing to the lists of many boards out there. And I think that's all I wanted to show you. Thank you for watching, and I hope that this project will go on and on. And that's all.